showed you before, you can hit the plus button here or the create button to create a new replet, and then you can search for the programming language, or you can just click it down here, Python. We'll just create a Python REPL. And then we can instantly start writing Python code in Replit. So, like I showed before, we got our different files here. We're just going to start by using one file here, and this is where you're going to encode, and this is where it's going to appear if we run the code. So I'm going to close off the list of files here, and let's just start at the beginning again. So you've gotten used to coding in Python through creating a rock, paper, scissors game, but now we're going to kind of do a deep dive into all the basic commands of Python. So there's going to be some review, but we're going to be going into more detail about each of the elements. And the first thing we're going to talk about is variables. So we can create a new Python variable by assigning a value to a label using the equal sign or the assignment operator. So let me give you an example. Just like I was showing you before, just name equals bow. So let me just zoom in a little bit more here. And so now our variable name is name, and we've assigned it the value of bow. And then we can also create a variable with a number. So I could do age equals 39. So a variable name can be composed of characters, numbers, and an underscore character. And it cannot start with a number. So it could be anything like name1. It could be all capital letters. It could have an underscore. It can start with an underscore, like I said, like that. And you can see that these are all, it's putting these red squiggly lines because it's showing that that's not actual Python code. If you're going to create a variable, you should be assigning it to a value, or you should be using a variable that already exists. But I'm just showing you some different examples of different variables. Now, so here's an example of an invalid variable name. If you just start with a number like that, that can't be a variable because you can't start with a number. And I couldn't put something like test exclamation point. You can't use exclamation points. You can't use percent signs. And other than that, anything is valid unless it's a Python keyword. So there's some keywords. A keyword is something that's used to write Python, like for, if, while, import. These are all words that have very specific meanings within Python, so you cannot use them for a variable name. Now, there's no need to memorize them, as the Python editor here will alert you if you use one of those as a variable. So that was just like, if I say if equals hi, and then you can see it's going to show you right here with these squiggly lines that we've done something wrong. Invalid syntax, because, and then also you can see that it turns blue. This word turns blue because it's a keyword. You can't use it as a variable name. So like I said, it's going to alert you if you use a keyword as a variable, and you'll start to gradually recognize them as part of the Python programming language syntax. Now let's talk about expressions and statements in Python. So an expression is any sort of code that returns a value. Like for instance, if you do 1 + 1, or if you just do a string like bow, this is going to return 2. This is going to return the string bow. So a statement, on the other hand, is an operation on a value. So for example, this is a statement here because we have an operation. We're assigning this to the variable. And then another statement would be like this, print name. So that's going to be a statement because it's doing something to the value. Now, a program is formed by a series of statements. And each statement is put on its own line, like we have these two lines here. But you can use a semicolon to have more than one statement on a single line. So I could put a semicolon here, and then if I run the program, it's still going to print the name. And let's just do that. We already learned how to run a program in Replit, which is just to click this button right here. But we can see it's going to print bow, and if I put these on two different lines, it's going to do the same thing. If I run the program, it's going to still do the same thing here. Now let's talk about comments. This is something we haven't talked about in this course yet. So in the Python program, everything after a hash mark is ignored. So if I put a hash mark, I can say this is a commented line. And when we run the program, this line is going to be completely ignored. And then we can also put an inline comment. If I just put the hash mark here, this is an inline comment. And the cool thing about most code editors, including Replit, is it's going to put comments, it's going to make them gray. So you know that this isn't really part of the program. This is just some sort of special note that the programmer wants to put as part of the program. So I want to emphasize again how important indentation is. So it's very meaningful in Python. So you can't randomly indent things. Like you can't just press tab here to indent here, and how this is kind of lined up here, this is lined up here. You can see this red squiggly line says unexpected indent. So some other languages do not have meaningful white space, and indentation doesn't matter. But in Python, indentation matters. So in this case, if you try to run this program, we can run this, and we'll see an error right here, showing up in red here. It says indentation error, unexpected indent, because indentation has a special meaning. So I can just unindent that here. Everything indented belongs to a block, like a control statement or a conditional block or a function or a class body, and we'll be talking more about those different blocks later. Now let's talk about data types. Python has several built-in types. So for instance, this is a string. So anything surrounded by quotation marks is a string. That's one data type. And you can check the type of a variable by using the type function. So I could say type, and then I'll put name. And to make sure to be able to see it in the console, I'm going to print what the type is here. And if I run the program, we'll see that the type is the class of str, which stands for string. And then we can test to see if something is a string by comparing it to str. So I could do equals equals str, and then if I run that, it's going to say true, because the type of name does equal a string. And then we can also use isInstance. So I'm going to, so if we, instead of doing type, we do isInstance, and then we have to pass it two things. So the first thing we're going to pass it, so we have the isInstance, we're passing it the name, that's this variable, and str, we're trying to see if name is an instance of a string. And if I run that, it should say true again. So we've been testing against the str class, the string class, but it works the same for other data types. So there are some data types around numbers. So an integer numbers are represented using the int class, or the int class. And floating point numbers, or fractions, are the type float. So I can say age equals 2, and then we can just check isInstance, and then I can pass in the age, and then I can pass in an int. So if I run that, we're going to see that I've done something wrong. Oh, I spelled that wrong. There we go. Okay, now I'm going to try this, and we'll see true, true. And I can also type in float, true, false. It's not a false, or it's not a float, because it doesn't have a decimal point. If I did 2.9, then it should show that it is a float, because it has a decimal. So Python automatically detects the type from the value type. So it automatically knows this is a string, it automatically knows this is a float, but you can also create a variable of a specific type by using the class constructor, passing a value literal or a variable name. Like, for instance, we have this, and we check to see if this is a float, and it's saying false. But I can make it a float by typing in float, and just putting the value into the float here. So we're going to make it a float. So now it's true, true. And you can do the same thing with strings or integers or other data types. And you can also convert from one data type to another by using the class constructor. So that's basically what we did. We just converted this from an integer to a float, but I can also do something else. I can convert something from a string to an integer. So for instance, we'll just get rid of this one completely here, and we'll just use this one. So a string is anything in quotation marks. So if I do 20, age 20, and I test if this is an int, it's going to say false. It's not an int, so I'm printing whether it's an instance of an int. But I can convert this string into an integer by just doing int here. And this, let me run the program, and it says true. Another thing about this is you don't just have to pass in the actual data or the actual string. I can pass in a variable. So I can say number equals, and now I'm going to make it, it says number, but it's actually a string. But I can pass in the number here, and then it's going to set that to age, and it's going to be true. So we create the string, we convert the string to an integer, and we tested that that age is an integer. So when we do something like this, this is called casting. It's basically trying to extract an integer from this string. Of course, the conversion might not always work, depending on the value that's passed. So, for instance, if we write test here in the string, instead of the 20, we may get an error. So let me just run this and see, now we have an error. It says invalid literal for int with base 10 test. So we can't convert the string test to an integer. So Python does its best to do the conversion, but it doesn't always work. There are a few other types. So let me here are some other common types of types. So there's the type of complex for complex numbers, bool for booleans, list for lists, tuple for tuples, range for ranges, are dictionaries, and set is a type for sets. And we'll explore all of these soon. We'll go into more detail about all these different types of types. Well, now let's talk about operators. We've already seen one operator, that's this one, that's the assignment operator. But there's also arithmetic operators, comparison operators, logical operators, bitwise operators, and plus some interesting ones like is and in. So we're going to be going over a lot of those right now. So we talked about the assignment operator, which is used to assign a value to a variable or to assign a variable value to another variable. Now let's talk about arithmetic operators. It's just what you use to do mathematics. So here are the different arithmetic operators. So we have plus, 1 plus 1 equals 2, then minus, multiplication, division. We have remainder. So 4 divided by 3 equals 1, but there's a remainder of 1. We have exponents, 4 to the power of 2 is 16, and floor division. So floor division does a division problem and then just basically rounds down. So floor division does the division and rounds down to the nearest whole number. So actually this would be better seen if we do 5 divided by 2. 5 floor division divided by 2 is going to be 2. Normally it'd be 2.5, but floor division is rounding down to the nearest integer, the nearest whole number. And then also note that the minus can also be make something a negative number. So I could do 4 plus negative, or I mean 1 plus negative 1, and then that's just going to equal 0. And then the plus operator can also be used to concatenate string values. That's something we talked about earlier, but I could say scamp and then put a plus is a good dog. And then like if I print this out, I put the parentheses around it, and then we'll see the whole string here. Scamp is a good dog. That was the name of my first dog when I was a kid. So we can also combine these arithmetic operators with the assignment operator. Well, let me show you what I mean. So let me just get rid of this here, and I'm going to do age equals 8 and age plus equals 8. And they'll do print age. So all these different operators can be combined with the assignment operator, and now it's going to add 8 to the age. So if I run this, it's 16. So this actually just means age equals age plus 8. So this age plus equals 8 is the same as saying age equals age plus 8. So it's just going to add this number to the current age and set it equal to the age. And you can do that with any of these. Like I could do times, and that would be age equals age times 8, and 64, and so on with any of these arithmetic operators. Okay, now let's talk about comparison operators. Now, we talked a little bit about them before, but let's see some examples again. So this is to compare if two things are equal, and then we have not equal. We're comparing them to see if they're not equal. This is if A is greater than B or more than B, and then this is less than or equal to B. Now let me just tell you a trick of how I keep track of which one is greater than and which one is less than. If you see this less than one, if you kind of tilt your head a little bit, it kind of looks like an L. See, like L. And this one doesn't look like as much of an L. So this less than operator kind of in some ways looks like a capital L that's kind of just squished over. And that's how I keep track of which one is less than and which one is greater than. And so these are all going to give either a false value or a true values. Speaking of true and false are examples of Boolean, the Boolean data type. The Boolean data type just means true, false, or true. So a Boolean is either going to be true or false. There's only two options. And there are a few Boolean operators. So let me show you what the Boolean operators are: either not, and, or. So when working with true or false attributes, those work like logical and, or, and not. So when you're using not, it means it's not true. You're checking to see if something is not true. And means they both have to be true, and or means either this one has to be true or this one has to be true in order for the full thing to be evaluated as true. And let me show you something about or. Now, or, used in an expression, returns the value of the first operand that is not a false value or a falsy value. Otherwise, it returns the last operand. So it's going to return the first operand that is not a false value, but since this is a false value, it's returning the second operand. Since this is a false value, it returns the second one. Since this is not a false value, it will return the first one, and this is considered a falsy value. If it's just an empty bracket, that's false, so it's going to return the second value, which just happens to be false. And since this is a false value, it's going to return the second option, which also happens to equal to false. So one way to think about it for the word or is, this is how the Python docs describe it. If x is false, then y, else x. So this would be like x, this would be y. If else is false, then y, else x. And then for and down here, let's look at some examples for and. And only evaluates the second argument if the first one is true. So if the first argument is falsy, such as false, 0, an empty string, empty brackets, it returns that argument. Otherwise, it evaluates the second argument. So the way the Python docs describe it is, if x is false, then x, else y. Okay, let's quickly discuss bitwise operators. They're very rarely used, only in very specific situations, but it's worth knowing what these bitwise operators are, just in case you're in the very rare situation that you need to use them. And then two other types of operators are is and in. Now, is called the identity operator. It's used to compare two objects and returns true if both are the same objects, if both are the same object. And I'll be talking more about that later in the section on objects. And then in is called the membership operator. This is used to tell if a value is contained in a list or another sequence. And we'll be talking more about the in operator when we're discussing lists and other sequences later in this course. And the final thing I want to talk to you about is the ternary operator. Now, the ternary operator in Python allows you to quickly define a conditional. So here will be like kind of the slow way to do it without a ternary operator. So let's say you have a function that, and this function is comparing age with 18, and it's going to return true or false depending on the result. So instead of writing it like this, we can implement it with a ternary operator. So let's do def is adult. I'll just call it is adult 2 because it's the second way of doing it. And this time we're going to use the ternary operator. It's just going to be return true if age is greater than 18, else false. So you can see first we define the result if the condition is true, then we evaluate the condition, and then we define the result if the condition is false. It's basically an if-else statement all on a single line. Okay, let's talk more about strings in Python. So a string in Python is a series of characters enclosed in quotes, in double quotes, or it could be single quotes, as long as the type of quote is the same on both sides. And we already talked about how you can assign a string to a variable. And we already talked about how you can concatenate two strings using the plus operator, like phrase equals bow, and then you can concatenate with the plus operator is my name. And then also, instead of putting a string here, you can put the variable. So I could put name is my name, and we already have the variable here to equal bow. So when you're concatenating, you can concatenate the strings or the variables. You can also append to a string using the plus equal operator. So let's say I want to add to this name, and so I'm going to say name plus equals is my name. So we're adding is my name to the end of this. So I can say print name. And then we can see what it looks like when you use the plus equal operator. So bow is my name. And then we already talked about how you can convert a number to a string using the str class constructor. Like if we had age equals, we could make this a string, but we pass this integer, it converts to a string, and now it's going to be a string. Now here's something new. A string can be multi-line when defined with a special syntax. So if you enclose the string in a set of 3 quotes. So let me show you an example. We'll get rid of all this, and I'm going to print an entire string here. So we're going to make this a multi-line string. I'm going to put 3 quotation marks, and then it's going to start with 3 quotation marks and end with 3 quotation marks. And then I can make it multi-line. So I can say bow is, and then I can put some extra lines. 39 years old. Now if I print that, and you can see it's going to print the different lines here. So we just made a multi-line string. And you can also, instead of using the double quotes, you can put a single quote, as long as they're the same at the beginning and ending. Now a string also has a set of built-in methods. Well, let me show you an example. So if I have this string, bow, but I'm going to put at the end of the string, I'm going to put dot upper. And I put parentheses at the end. So if I run this, now it's going to print it in all capital letters. And the same thing you can use with lower. So if I had a string that had a few capital letters, okay, now it's all lower. Now I can also type in a title, and this is going to make each so I can say bow person, and I do this. So it's going to a title is going to make the first letter of each string a capital letter. I could also check things, like I can say is lower, and it's going to check if it's all lowercase letters, false. But if I make it so it is all lowercase letters, it's going to say true. So here's just a list of a few common ones. You can do is alpha to check if it contains only characters, is LNum to check if a string contains characters or digits and is not empty, is decimal, lower to make it lowercase, is lower, upper is upper, title starts with to check if it starts with a specific substring, to check if it ends with. You can replace part of a string, split a string, you can strip the white space from a string, you can append new letters to a string, you can find the position of a substring string, and there's a few more, but these are some of the most common things you can do with a string. And then one thing to know about these is that they all return a new modified string. They don't actually alter the original string. So let me show you what I mean by that. So let's say we'll do name equals bow again. Let me zoom in a little bit, and we're going to print name.lower. Now I'm going to print name. So if I just run this, and we first figure out what went wrong here, it looks like there's a few extra parentheses. Okay, let's run this, and you can see it's gonna make it all lowercase, but then when I print the name again, it's not still lowercase, because this just returns a brand new modified string. It doesn't actually change anything in the original string. And then you can use some global functions with strings as well. So one function we haven't discussed yet is the len function, which stands for length. It can give the length of a string. So I'm going to type in len, and then, so there's just some global functions that work with a lot of different types of data, and the length of this is 4, you can see. And then you can use the in operator. Now, I briefly mentioned the in operator earlier. So let me show you one use case. So we can use the in operator to check if a string contains a substring. Like, for instance, I can say AU in name. So let's check if name contains the letters AU. Well, true. It does, but if it didn't, if I just add an extra string, it's going to say false. Okay, another thing with strings, escaping is a way to add special characters into a string. For example, let's say we wanted to add a double quote within the string. How can I add a double quote into a string that's wrapped in double quotes? If I put a double quote like that, that's not going to work, because this is going to be the string, and then it's not going to, the code editor is not going to know what to do with this last little bit here. So the way to go is to escape the double quote inside the string with the backslash character. So right before this quote, I'm going to put the backslash character, and then you can see it now is all the same color as a string. And if I print it, it's not going to print the backslash character. So putting a backslash is how you escape a character, and that just means the backslash character means that the next character is not going to mean what it normally means. It's going to actually just be the string of that character. And you can do the same thing with, in this particular example, you may not need to do it because you can always just put a single quote at the beginning and ending. And as long as you have a different type of quote at the beginning and ending, then you can put a double quote in the middle. But let's say you want a string that contains both a single quote and a double quote within the string. Then you will have to backslash. Like if I just put a single quote there, it's going to mess it up. But if I put a backslash, now it's going to have the double quote and the single quote right within the string. And you can also use the escape character for special formatting characters. Like, for instance, what if I wanted there to be a new line between the first two and the last two letters of the string? If I do /n, that is going to not actually just put a /n. Let's see what happens when I put that. This means new line. You can see it says BE, new line, AU. And then another way, a reason why you may want to use an escape character, like let's see what happens if I do this. That's not looking how I want to look, because it's normally when the code is running, if it sees this backslash, it thinks it's an escape character. So if you want to actually add a backslash to a string, you have to escape the backslash. So now it's BE backslash AU. Okay, we're done talking about escape characters. Now I'm going to tell you how you can get a specific character in a string. So given a string, you can get its character using square brackets to get a specific item, given its index starting from 0. So one thing to know about programming is that whenever you're counting in most programming languages, you start counting starting at 0. So this is going to get the letter at index 1. So this is index 0, the B. The E is at index 1, index 2, index 3. So if I run that, we can see we are getting the E that's at index 1. If I want to get the B, I just put a 0 in the brackets, and we get the B. And then we can use a negative number to start counting at the end. So if I put -1, it's going to start here, 0, 1, and that's going to be A. Oh, U. Okay, I guess when it's going backwards, it's not going to start 0 because there is no -0. That makes sense. So -1 is going to be the last character in the string, so -1, -2, -3, and so on. We can also use a range using what we call slicing. So if I put 1:2, this is going to be every character starting at index 1 and ending before index 2. So it starts at index 1, so it starts with that character, and it ends before index 2, which is A. So that's actually only going to return an E. But if I put 3 here, now we can return AU, and if I put Bo is cool, we can put one further down. I'm going to put 7, and we can see it's going to return part of this string. And then you can also start, if you just put a blank before the colon, then it's going to return everything up to, it's going to start at the beginning and return everything up to character 7. And you can also do it in the opposite direction. So if I put a blank after the colon, it's going to go to the end of the string. So it's going to say is cool. So let's talk about Booleans. Well, we already talked about Booleans, but we're going to talk a little bit more about Boolean, which is considered the bool type. And this can have two values, true or false. So I can say done equals true, or you can do done equals false. Now, notice that it always has a capital T or a capital F. So if you don't put a capital T or a capital F, it won't be considered the true Boolean value in Python. And Booleans can be especially useful with the conditional